Evaluating.
We need to take our own motion.
Yeah, oh my god. Absolute value expression. So first thing that comes out is kind of like, so what is the absolute value? And what we're interested in this case, let's say we have a number line. And on the number line I got 0, I got 3, and I've got -7. And if I ask you, so how far from 0 is 3? How many units is this? 3. How far is it from -7 to 0? 7 units, right? I'm asking you how far. I mean, it generally implies, you know, how far do I have to walk or that? Like what's the distance as opposed to, you know, is it a negative distance or positive? Well, why does that matter? How far do I have to go? You know, if I'm driving my car, does it matter if I'm driving from here to Edmonton or Edmonton to here, right? How far am I going? So if we put here in Edmonton on a number line, then Edmonton could be positive 300 kilometers, could be negative 300 kilometers, but we're just going to say it's 3. So if we're interested in the magnitude or the size of something, we take its absolute value. So here we say the absolute value of 3. And what we use is a set of vertical lines. Okay, so you see vertical line in front, so that's not 131. That's a set of vertical bars surrounding the 3. And the absolute value of -7 is 7. So absolute value is a function which has to think. Okay, most functions just do, right? I give you something like, you know, y equals x squared plus 7x plus 12. To make a table of values, and you just, okay, I got to square the x value, then I have to multiply it by 7 and add that on, and then I'm going to add 12. Right? Does it matter what the x value is? Nope, just going to always do the same thing. Absolute value function has to say, if I want to take the absolute value of a, so we're going to define it. The absolute value of a. So what if a is already positive? What do I do to it? Nothing, right? I'm just going to return it to you. If you give me a positive value, I'm going to say, well, the absolute value of that value is whatever the value you gave. So if a is positive, or another way to say that, if a is greater than or equal to 0, then the absolute value of a is just a. But what if a is negative? What do I have to do to it to turn it positive? Yeah, flip the sign, but how can I do that? What operation could I do? If I give you -7, I want you to give me back +7. What are you going to do?
Multiply by -1.
Multiply it by -1, right? So the absolute value of a is equal to a if a is greater than or equal to 0, and it's equal to -a if a is less than 0. Okay, so the absolute value function actually has to do some thinking, right? I mean, if it's programmed into a computer, it actually has to look at it and say, well, so is it positive? Yeah, okay, then I'm just going to give it back to you. But if it's negative, then I have to take the negative of it, right? And the negative of a negative is positive. Okay, and this is going to come in, this idea, this definition is going to come in throughout math. I mean, for the next year, well, this rest of this year and all of next year. All right, so let's say we do this. What's the absolute value of 3 minus the absolute value of -7? So here we have two absolute values. So treat an absolute value like a set of brackets, right? It just says do whatever's in there. So what's the absolute value of 3? 3. Now, because there's absolute values around here, do I change this minus to a plus? No. So it's 3 minus, what's the absolute value of -7? 7. What's 3 minus 7? -4. Okay, so just because there's absolute values in there doesn't mean that the expression automatically becomes positive, right? If I want to make that expression positive, what I can do is this. Throw another set of absolute values around there, which means that you would then say, well, that's like an outer set of brackets, right? I have to do the inner set. So here's the outer set of brackets. So here's the outer set of brackets, and then that's equal to positive 4. Okay, so if I really want to take the absolute value of something, then, I need to surround the entire expression. Okay, try this one. 3 times the absolute value of negative 5 plus 2 times. Okay, so work that out. So what you're going to do, again, just treat the absolute value sign like a set of brackets. So if there's an expression inside, like 12 minus 20, then you have to evaluate that first. And then you're going to do the absolute value. So think of order of operations, bed mass. So this will be 3 times 5 plus 2 times the absolute value of negative 8. And I think somebody said 31. Yeah, it's equal to 31. Okay, so we treat absolute value of 12 minus 20 like it's an expression in parentheses, right? We evaluate 12 minus 20 is negative 8, but we're still doing the absolute value, right? And the absolute value of negative 8 is positive 8, and 2 times 8 is 16, and so on. Okay, let's try this. Okay, try that one. So absolute values nest, just like brackets do, right? So I have like an inner absolute value here, an outer absolute value here. So I'm not going to remove that outer absolute value until I've evaluated whatever's in between them, right? So I need to get 3 times negative 4 squared plus 5 times negative 7 plus the absolute value of negative 3 down to a single value, which will be inside the absolute value, and then take its absolute value. So I can just start applying order of operations. So negative 4 quantity squared is 16. I've got 3 times 16. Plus 5 times negative 7, that's just regular parentheses. 5 times negative 7 is negative 35. So plus negative 35, just write that as minus 35. Plus the absolute value of negative 3 is 3, so plus 3. So we got 48 minus 35 plus 3. 48 minus 35 is 13, plus 3 is 16. And the absolute value of 16 is 16. So we didn't have to do anything. Those outer absolute value, the outer absolute value sign or operation had no effect on the final answer since it was positive, right? An absolute value says if the value in between is positive, then you just leave it as it is, and if it's negative, you change it to positive.
It's minus 16.
All right, what if I have 2 points? I got the point A, that's 7, negative 3. And I got the point B at negative 5, negative 3. And I say, how far is it from A to B? Gentlemen, do you need something? Getting him caught up? Okay.
Yeah.
Are you caught up? Good.
Almost.
All right. Because I'll pause. You can just take a moment. All right, what's the first thing you should do with any of this stuff? Draw a picture, right? That's my advice for you for Wednesday. Draw pictures, draw a diagram, label the information on the diagram, especially if you're not really sure where to start, right? At least you're asking yourself, what information do I have? Okay, let me draw a picture. What does it look like? What am I supposed to find? You gotta figure that out. I mean, usually it's like the last sentence, if it's a word problem. What am I finding here? What's my plan? Gotta make a plan. What is that I'm gonna use? Oh wait, there's a formula that I can use. I'm gonna use the quadratic formula or something. So, oh, I'm gonna use the value discriminant, right? B squared minus 4AC, and they said there were no real roots, so I know that has to be less than 0, right? So you start filling that stuff in, right? That communicates to everybody involved. This is what's going on in this question, right? I'm going to work out b squared minus 4ac is less than 0. They use k's, and I've got to work out the value of k, and away we go. All right, in this case, so I need the point A at 7, negative 3. And I'm going to label it. I'm not just going to drop down a point and put nothing there, right? I want to say this is the point 7, negative 3. And it's point A. I've gone like 7 this way and down 3. I can't say my scale's perfect.
Sorry.
Okay, so B, I'm going negative 5, negative 3. So I shouldn't be as far away, but I should be the same level, right? I mean, the important thing here is these guys are on a horizontal line. Okay. Okay. They don't have to be perfect, but they should be in relative position, right? Which means what they need to be is they do need to be on the same horizontal line, right? They do need to be where this is negative 3, right? I mean, I could label that 7 and negative 5, but but label the point anyways, right? So we give you a diagram. We say what's the quadratic function? Right? So you figure out, okay, I've got the vertex here, so label the vertex, right? If it's at 1, 4, put down a bracket 1, comma 4, right? That'll help you when you then go to do the vertex form, right? And you'll write down y equals a bracket x minus p quantity squared plus q, saying, okay, this is the formula I'm going to use, this vertex formula. This is the vertex. Here's another point on there, right? What do I have to do here? Okay, I've done this like 100 times before. So at this point, I know what to do to solve the problem. Okay, and I've got my numbers laid out and everything's good. Okay, so how far apart are these guys? 12. But we need to be able to come up with ways. We don't always want to draw diagrams necessarily. I mean, what if A is at negative 517? And it's like, I don't want to scale this. So using the 7 and the negative 5, how are you getting 12?
7 plus the absolute value of 7 plus the absolute value of 5 is 12.
Okay, let's go with, I could do this a couple ways, right? I can say, well, we can go from, so what I really need is what's the difference between the x coordinates, right? The y coordinates are the same, they're both negative 3. So what's the difference? Because the difference between them will be how far apart they are, okay? So you could say, well, I'm going to go negative 5 minus 7. And that's negative 12. And you say, wait a sec, we want distance. How do I get distance? Well, I'm going to do the absolute value of that, and then I'll get a distance, right? So taking the absolute value is going to give you a distance. And you say, fine, you went from B to A. What if I go from A to B? What if I go 7 minus negative 5? 7 minus negative 5 is 7 plus 5, which is 12, right? I don't need no absolute value. I don't need any absolute value. Okay, but we're going to put that on, right? We're just going to say no matter what, because it doesn't matter what order we go in, right? This way, it doesn't matter what order we go in. If you go negative 5 minus 7, we're doing absolute value, right? So it's the absolute value of the difference between the x coordinates will give us the distance, right? Now the expression we get in one of them is negative 12, but we're doing the absolute value, right? Because we know distance is positive. Okay, and maybe on Wednesday you're working something out, you're getting a couple of different values and you're rejecting one. You're saying, x is negative 2 or x is 6. but I'm looking for the width of the pool deck, and it can't be -2. So I'm going to show you, look, x could be -2, and then I'm going to cross it out, say, but in this context, that doesn't fit. Okay, so then I'm rejecting that. So it's extraneous, right? Okay, so that's distances. So let's do some distances. So let's say we got a football game going on here. And we got the ball is on the 35-yard line. Now we want to get into the end zone, right? Well, how far is that? Well, it's 35 yards, right? If we score, we will have moved the ball 35 yards. But the question might be, well, in a series of plays, though, not every time does the ball go forward, right? Sometimes the ball goes backwards. Sometimes we're penalized and the ball moves backwards. So I want to say, well, let's run through a little scenario here of taking the ball and seeing if we're going to score and how far the ball travels. So, if you drive from here to Edmonton, if you set your odometer at 0, your trip thing at 0, what's it going to read when you get to Edmonton? Like 300, right? About 300. Okay. And you fill up in Edmonton, you're using this trip thing just to see how far you've gone between fill-ups, and you reset it to 0 and you drive back to Calgary, what's it going to read? Same thing, 300, right? Because it doesn't care which way you're going, right? And with the car, we don't really care that. Like if I drive, hey, anybody study physics? Yeah. So you heard the word displacement? Okay, so you started at home this morning, right? You are now some distance, you've traveled a distance to get here, right? And your displacement is whatever. So let's say, in my case, my displacement is about 2.2 kilometers, and we'll go roughly north. Okay, not exact, but I've traveled a distance of 2.2 kilometers. Okay, now I go home. What's the total distance I traveled during the day? 4.4. What's my displacement at the end of the day? 0, right? Because I'm just back where I started. Okay, so little Pokemon down here, right? He doesn't care about displacement. He's measuring distance, right? Number of steps. I could convert that to distance. Okay, so we're interested in is like there's a little odometer in the ball, and we want to know how far has the ball traveled during its journey from the 35-yard line to the end zone. All right, so first play, 10-yard pass. Okay, how far has the ball gone? So we go 35, well, that's where you started, this is where you ended up, which is 10. Okay, second play, handoff, stopped in the backfield of the 28-yard line. So you started on the 25, and you went to the 28, so how far did you go? -3. Well, you lost 3 yards, right? And that's exactly what David said. It was a loss of 3 yards. Okay, but how far did the ball travel?
3 yards.
3 yards. How far has the ball gone in total? 13 yards, right? All right, so how are we going to capture that? We're going to say we are interested in distances, so we are doing absolute values of everything. So that this final column will be the distance the ball traveled, not its displacement, right? Its displacement now is like 7 yards, right? Like from its starting point, it's been displaced 7 yards. All right, so what happens on the next play? On the next play, we end up on the 15-yard line. Got a nice little pass and run. So we started on the 28. We ended on the 15. That's 13 yards. And it was in a positive direction, at least for us, right? If you're on defense, then that's probably like a negative direction because we gave up 13 yards. Okay? So it's all your point of view, right? If you're offense, that's positive 13 yards. If you're defense, like we just gave up, a 13-yard play. Next play, penalized for holding. Ball's marched back. Started on the 15, ended up on the 25. How far is that? 15 minus 25 is -10. but the ball has traveled 10 yards, right? The ball has a little GPS in it or odometer, and we're just measuring, you know, how far has this thing gone. All right, what happens on the next play? Oh, handoff, and it goes for 20-yard run. So we started on the 25, we ended on the 5. That's positive 20 yards, right? That's for the defense, and that's like we gave up a 20-yard run. And then what happens? Illegal procedure, 5-yard penalty. Started on the 5-yard line. We end up on the 10-yard line. For us. So if we're looking inside these absolute value bars, it's telling us what happened, right? That was a loss of 5 yards. If we're the ball, we're just interested in how far have we gone. It's like, okay, so we've moved another 5 yards this time. And a little pass play right to the goal line. So we started on the 10, we ended up on the 0, and that's a total of 10 yards. So how far has the ball traveled? What do we got? 13, 26, 36, 56, 61, 71 yards. So the ball, what's the ball's displacement? 35 yards. Okay. But what's the distance it traveled was 71 yards. Okay. How do we find that? Really just, where did you start, where did you end? Okay. You've taken your dog out for a run, and you know they're not just, you know, they're back and forth and hither and yon and that. If you have a little GPS on, there's tracking distances, right? Or so you can find them if they get lost. You saw the commercial, right? Where's the dog? Track it down by the GPS column. You know, you can go back home, you can plot the route and see how far the dog went. You know, so gee, I walked like 2 kilometers and the dog went like 6 kilometers.
Does like sideways distance matter?
Yeah, we're not going to do that, right? You'll learn the distance formula in Math 31. It's like, should have done it last year. Right. Yeah. So what happens if it's moved on an angle? Yeah. And so all we're assuming here is everything just went straight up and down the field. Yeah. Which is totally unrealistic. Right? But for the sake, otherwise we'd be working out diagonals. Right? I mean, you do it. You just use Pythagorean theory. You just make a triangle, right? Because you can make a right triangle. If you say, okay, look, so the ball started here and it was thrown out to here, then it went this far and this far. Okay, so I know this, and then I can take the square root of this squared plus this squared. That's the distance formula, right? Yeah. How far has something moved on a, you know, and if it's like if we went back here, you know, what if the points, what if a point was here? Well, then you'd say, okay, you can take this distance, and that makes a right triangle, right? I've got a vertical distance and I've got a horizontal distance. That can make a right triangle. You just do the square root of this distance squared plus this distance squared. Simplifying, right? Big point for tomorrow. Not tomorrow. Tomorrow's like review. Although we're pretty much done this, so you're going to have time now, right? So you're not worried about this particular unit's homework, like this, whatever assignment. You can do that over the break, right? You got lots of time for that. So you need to worry about, okay, did I go through quiz 1? I'm going to give you back quiz 2, okay? And you can look at the, well, we don't need this anymore, right? So we're pretty much done this. So it's just the idea of absolute value and how to calculate it.